So this time around, we are going to look at bicimals. Just like you have decimals in base 10, so you have bicimals in base 2. Please take note. Just as you have decimals in base 10, so you have bicimals in base 2. So we are familiar with base 10 fractions. We are familiar with that. This is what we have been doing over the years. We are familiar with base 10 fractions or decimals. Base 10 fractions or decimals are based on negative powers of 10. I'm going to explain that clearly to you. The number 3.672 is a number in base 10. And we know what it means. 3 is on the integral part. 672 on the decimal part. How do we explain them? Please pay attention and see how we explain the place values of these digits. This 3 is 3 times 10 to the power 0. That's how you got the 3 there. 3 times 10 to the power 0. And what gives you 3? Now when you come to the decimal part, this 6 is 6 times 10 to the power minus 1. Because 0.6 means 6 over 10. 6 over 10, remember our indices, is the same thing as 6 times 10 to the power minus 1. If you go to 7, it means 7 times 10 to the power minus 2. You go to 2, it means 2 times 10 to the power minus 3. That is their positions in base 10, which we are familiar with. And I'm sure many of us have been doing things like this without understanding clearly what we are doing. So I want you to understand very clearly that the number 3.672 simply means 3 whole numbers, which is a 3 times 10 to the power 0, because you are working in, that number is in base 10. How do you get this 3? It is 3 times 10 to the power 0. Now you come to the decimal point. You are now considering the digits after the decimal point. This 6 here is 6 times 10 to the power minus 1. That is how you get 0.6. This 7 stands for 7 times 10 to the power minus 2 by each position. And this 2 stands for 2 times 10 to the power minus 3. That's how they got their positions. And that is why I told you that they have negative powers. The decimal part has negative powers, as you can see. Minus 1, minus 2, minus 3, and so on and so forth. Now, we can carry this idea to base 2 to talk of bicimals. We now want to talk of bicimals, following the close example of what we discussed in decimals. So similarly, we can have base 2 fractions or bicimals based on negative powers of 2. The other one was based on negative powers of 10, because we are talking about base 10. Now in base 2, you talk about negative powers of 2. So if you have a number like 1.1011 in base 2, how do you explain the digits? Please pay attention. It is in a similar way as we explained in base 10. This one represents 1 multiplied by 2 to the power 0. Just like you had 3 times 10 to the power 0. Here you have 1 times 2 to the power 0. That's how you got the 1. Then when you go over to the decimal part, this one here will be 1 times 2 to the power minus 1. This 0 is 0 times 2 to the power minus 2. This one is 1 times 2 to the power minus 3. The second one is 1 times 2 to the power minus 4. And so on and so forth. Just like we had it in base 10. I hope it is understood. So to convert a decimal number to a decimal number, we first express each digit as a power of 2. That is exactly what we have done there. As it is now, if I write out these values now, I am getting something in base 10. I will get something in base 10. That is the conversion. That is exactly what I'm saying here. We express each digit as a power of 2, then change the powers to fractions. 1 times 2 to the power minus 1 is something as half. 0 times 2 to the power minus 2, of course, is 0. But 1 times 2 to the power minus 3 is something as 1 upon 2 to the power 3, which is 1 upon 8. 1 times 2 to the power minus 4 is something as 1 over 2 to the power 4. Which of course gives you what? 16. So this thing now will be half plus 0 plus 1 over 8 plus 1 over 16. That is what this is telling you. You express each digit as a power of 2. That is what we have done there. Then change the powers to fractions. That is how you can convert a decimal number to a decimal number. We are going to look at some examples so as to make you to understand very clearly, because many people find it difficult to handle this decimal. But by the time you relate your ideas to what you know or what you do in base 10, you'll be familiar or you'll be at home with decimals. So let us see some examples. So we have to look at some work examples to understand very clearly what we are saying about decimals. Convert the following decimals to decimals. A 1.1011, B 10.011. I want to caution here that we have to be careful the way we read numbers when we come to number basis. For instance, I'm saying 1.1011. Here, I'm saying 10.0111. I'm not saying 10.0111. I'm talking about 10 because I'm not working in base 10. I'm working in base 2. So any other base you are working on, you have to be very careful the way you read the digits in any number, because you may read the digits as if you were in base 10 and you can get confused. So try always to read the digits in a reading form. That is, I'm saying 10.0111. I'm not saying 10. Just like if we have any other number in any base, you try and read the numbers digit by digit. Don't read the number as if it is a number in base 10. Now, to answer these questions, you can look at what we have here. 1.1011 in base 2 is equal to 1 times 2 to the power 0, and is under that unit, plus, now we are going to the decimal part. This one is 1 times 2 to the power minus 1. This 0 is 0 times 2 to the power minus 2. This one is 1 times 2 to the power minus 3. And this last one is 1 times 2 to the power minus 4. That is following the place values. You come down, and you get something like this. You come down, you get something like this, and finally get something like this. And finally you end up with that. So 1.1011 in base 2. I have to take note that this is in base 2. Is equal to 1.6875 in base 10. In base 10. Base 2. Base 10. 10.0111 in base 2 is equal to, this 1 is 1 times 2 to the power 1. This 0 is 2 to the power 0. That is following our place values. Then plus 0 times 2 to the power minus 1, 1 times 2 to the power minus 2, 1 times 2 to the power minus 3, 1 times 2 to the power minus 4. Following our place values. And now you simplify all that and you end up with, you can see that this 10 in base 2 represents 2. That's why we're having 2 in this in base 10 now. So this in base 2 is equal to this in base 10. Please take your time to go through the word examples. And I believe you can attempt converting Bicimals to decimals. May God bless all of you in Jesus' name. And that brings us to the end of what we have to do in number-based system. May God bless all of you.